Okay, today we're going to be talking about finding nth roots. You probably have seen square roots. Now we're going to talk about nth as in third, fourth, fifth, 10th, whatever roots. Here is the vocabulary that you need to know over here. Make sure that by the end of this lesson you know the vocabulary, or if you don't, if you're still confused, that you write it down and ask about it tomorrow in class. If you look over at the over here, you can see an example of where everything is. The index tells you what root we're looking for. The radical sign just shows you that it's a radical, and the radicand is the thing underneath it. So in example A, the radicand is the thing underneath the radical sign. That's 23, and the index is 3. Make sure you can check the rest of these. Be sure also that you note that the radicand is negative 343 and include that negative sign, and the index is 5. Okay, on this one, we're going to look at how you find relating square root of numbers and squaring a number that they are inverse operations of each other. When you do a square root, you're looking for what number multiplied by itself will give you the original number back again, the radicand back again. When you see the square root sign, note that we're looking for the positive square root. All the time we want to have the principal root, which is positive. This is very different than trying to solve x squared equals 100. In that case, we're looking both for the positive and the negative, all the possible solutions that would do that. Down here, where we're looking for the square root of 100, we just want the 1. We want the square root of 100 is 10. The square root of 25 is 5. Be sure when you're thinking about fractions, down here for example, that you do the square root of the top and the square root of the bottom, and that you do them in fraction form. It's a lot easier. When you have one that's like this one, that is a decimal here, it's best to rewrite it as the square root of 36 over 100 and think about it as 6/10 and then reduce it to 3/5. Way easier, especially if you don't have a calculator. You should be responsible for knowing and recognizing all of the perfect squares up to about 16 or 17 or so, plus a couple others like 25 squared. You'll need to know those, and you'll need to recognize them backwards. Pause the video, take a minute, do all these problems on your worksheet, and then when you think you've got them, come back and check them on the next slide. Okay, here are the answers. Check them. Make sure you understand the ones about that down here with the fractions, and make sure you understand why this one doesn't exist. You're taking the square root of a negative number, and that doesn't exist. Same thing here. If you have any questions, again, write them down so that you can ask tomorrow in class. Okay, here are ones that are not square roots. We're still asking for the principal square root, but when the index is odd, like in this one, it doesn't matter whether we can take with an odd index, we can use a negative number, because when it's the third root, we're really saying what multiplied by itself 3 times will give us negative 64. Well, we're going to need a negative number in there, negative 4, and negative 4, to get the negative in our answer. So odd roots with negatives are fine. Evens, we're asking for the principal root. So for the 6th root of 64, we're asking for, here, we're asking ourselves what would multiplied by itself 6 times would give us 64. Again, with the fractions, keep them in fraction form so that it's easier to think about this. You really want the cubed root of 1 divided by the cubed root of 27, and that's going to give you the 1/3 that you want for an answer. So again, take a minute, finish these on your worksheet, check to be sure that you have them, check your answers, make sure that they're okay. Okay, for this one we want to look at what to do for the cube root of 24 when 24 is not a perfect cube. We want to be able to break that down into perfect cube times another perfect cube. And you can see up here that we're going to be using the product property of radicals. We're able to break a product down into its component pieces and do the cube root of each one, which is, I think, what you would expect. So we're looking for a perfect cube. We want to break 24 down into as many perfect cubes as we can, and then whatever's left over. So there's lots of ways to break down 24. Could be 24 times 1, 12 times 2, 8 times 3, 6 times 4, but we want to pick the one that is a perfect cube. So we're going to pick 8 and 3, and here's where it helps to know your perfect cubes. So cube root of 8 is 2, and then we have the cube root of 3 left over. So let's go back and try one with a bigger number. 720, we're looking to break that down into the fourth root of something that's perfect, and then the fourth root of everything else that's left over. So we start thinking about what fourths do we know. 1 to the fourth is 1, that doesn't help. 2 to the fourth is 16. 3 to the fourth is 81. And then we're probably too big. You can try 4 to the fourth is 256. It looks like maybe 81 or 16 would work. 81 has those 9s in it, but looking ahead, I know that 16 is the one that I want. This is going to be 16 times 45. The fourth root of 16 is 2. 45 breaks down into 9 and 5, but neither one of them is a perfect 4. 9 is a perfect square, but not a perfect 4. So I'm going to leave it as 2 times the fourth root of 45. Okay, thinking about 189 again, I want to know how would that break down. I need a perfect cube. I'm not thrown by the negative sign because it's a cube. So I'm thinking 2 cubed, 8. Nope, that's not going to work. 3 cubed, 27. That might work. 4 cubed is 64. Probably not because it's even. So let's try the 3 cubed. That's going to give us 27. And that times what is 189? So 27 times 7 is the 189. That's what I'm looking for. Whoops, get the pen back. 7. And then I can say, oh, okay, cube root of 27, that's 3, and then the cube root of 7 left over. Okay. I need a negative sign. I forgot the negative from the 189. I just want to put the negative right in there. Try these ones up at the top, or try the rest of the ones on your worksheet. And then here are the answers for those. Make sure that you understand how to get all of these. Oops, I forgot the negative on the previous one. Let's go back. Okay, try these up at the top. Make sure you understand them. You can do those. And then let's look at what happens with the variables. So pause, do those, come back, and then we'll look at the variables. All right, for variables, we're thinking about how many perfect, in this case, 3's are in there. So we're thinking groups of 3. In x to the third, how many groups of 3 are there? Well, there's 1. That's what we put on the outside. 1 group of 3. We know our group size is 3, and this tells us how many groups of that size are 3. In this one, our group size is 4, so we want to think about, in x to the fifth, how many groups of 4 are there? Well, there's 1 with 1 left over. So I put my 1 group on the outside, and then I say, and there's 1 left on the inside that couldn't form a group. In this one, I'm looking for groups of size 3. In my A's, I have 1 group of 3 A's, so I put that on the outside. If I have 10 B's, I can think about that as 3 groups of size 3, and then 1 is left over, has to stay on the inside. If I combine this with numbers, I'm looking for square roots in this one, so I'm looking for groups of size 2. Well, for the Y's, if I have 3 Y's, that's 1 group of size 2, and 1 Y left on the inside. But I also need to think about the 12s. That's got a perfect 4 in it, so that comes out. Square root of 4 is 2, and that leaves me with a 3 on the inside. try these other ones, pause the video, and then let's come back and look at the answers. For this one, I'm looking for groups of size 4. In 16, that's a 2. For the A's, there are 3 of them on the inside. They don't make a group of 4, so I have to leave them all on the inside. B to the 8th, that's 2 groups of size 4 with nothing left on the inside. For the C's, I have 16 C's. That's 4 groups of 4. So they come on the outside. For this one, for the cubes, I have a 10 on the outside because 10 times 10 times 10 gives me 1,000. The 5 is left on the inside because that's not a group of size 3. I have to leave the x on the inside. I have to leave the y squared on the inside because that's not big enough to make a group of 3. But I have a z on the outside because that's z to the 3rd. That's 1 group of 3. And then for this last one, that's a -2 on the outside because 2 to the 5th is 32. There are 2 groups of size 5 in the m's, 1 group of size 5 in the n's, and 2 of them are left on the inside. Okay, practice these and then check to be sure that you got the right answer. Also, be really clear about why this one works and this one doesn't. What's the difference in those? Again, if you have questions, write them down and bring them into class tomorrow.